Hi, I'm David. So for this one, we're given a word problem where they're saying that there is a conservation organization that is releasing a bunch of endangered animals into a game preserve, and that the population of these animal species follows this type of function, where T represents the time or the months, the number of months that passes by, and P of T, the function P, represents the total population of the animals that are being released into this game preserve forest. And so in order to solve the first part of the problem, let's see what they're asking. They're asking for what the population is after 5 months. And let's recall that months is T, so all we have to do is take 5 and plug it in for T. So that becomes 1,000 divided by 1 plus 9 times e to the power of negative 0.1656 times 5. And we can just use our graphing utility, our calculator, to solve this. It's much more simple. And if we input these numbers into our calculator, you will get roughly 203 animals. Meaning, after 5 months, this forest will have about 203 animals. Now, secondly, they're asking, when will the population equal 500? So now we're solving this backwards. So now they want us to take the 500 and plug it in to P of T, meaning the equation is going to look like this. 500 is equal to 1,000 all over 1 plus 9 times e to the power of negative 0.1656 times t. And now we're trying to solve for t. So in order to solve for t, we want to isolate this, right? And so the best way to do this is, let's first multiply everything on the denominator to the other side of the equation. This way, we can remove any fractions that exist. So if we take this and multiply both sides by this, we've removed it from this denominator and moved it to the other side. So we would be multiplying 500 times 1 plus all of this. That will give us 500 plus 9 times 500, which is 4,500, e to the power of negative 0.1656 t is all equal to 1,000. Right? And now we can continue to isolate. Now we can subtract the 500 from both sides, so that way we remove it from the left side, which reduces 1,000 down to 500, because we've subtracted 500 from both sides. Awesome. And now we want to divide both sides by this coefficient of 4,500 right here. Because again, we want to isolate the t, so if we divide both sides by this, we're leaving just the e and its exponent, right? So let's move over here. If we divide both sides by this number, we're going to get e to the power of negative 0.1656t is equal to, let's see, 500 divided by 4,500, that is going to be 1/9. Cool. And so now we can solve for this t a few different ways. We can switch this exponent into a logarithm. We can do the natural log of both sides. By doing the natural log of both sides, we're able to cancel out the e with the natural log because the natural log has a base of e. And when the base and the argument are the same, they're able to cancel out. But of course, if we take the natural log of one side, we have to take the natural log of the other side. Meanwhile, if you recall the power rule, we're able to now take this exponent and move it to the front of this part of the equation. So then that gives us negative 0.1656t times the natural log of e, which is equal to the natural log of 1/9. And like we said earlier, this part cancels out. And so now all we're left with is negative 0.1656t is equal to the natural log of 1/9. And I can use my calculator to solve for the natural log of 1/9. That is roughly negative 2.197, rounded to 3 decimal places. Meanwhile, over here, we'll just drop this down. And then the final step to isolate the t is to divide both sides by this number that is multiplying the t right now. So if we do it to one side, we got to do it to the other side. So we're dividing by negative 0.1656. This cancels out. So now we're left with t is equal to this, and we can just plug this into our graphing utility, into our calculator to solve. And the answer here is roughly 13.3. But we can just round it to 13 because they're asking us how many months it would take. So we can just round it to a whole number. So it's going to take roughly 13 months for the population to reach 500. Next, they want us to take this function and graph it, right? So we can turn on our graphing utility, go to y equals, plug this in. Remember to put parentheses around the bottom part, around the denominator, just so we don't mess this part up, and also to put parentheses around the exponent, just so everything stays lined up. And after we enter all of this in, we can press graph. We'll see a logistic curve show up. And we can always adjust the window as well. I adjusted my window to 0 to 100 on the x-axis and 0 to 1,300 on the y-axis. So now you can see the logistic curve. And with these logistic curves, there are two horizontal asymptotes. There is one towards the bottom and one towards the top. So we can do trace. We can trace it and see exactly where those asymptotes are. As you move right, as you move into the positive direction, you'll see that the asymptote approaches p equals 1,000. And meanwhile, on the other side, on the negative side, if you keep moving your cursor left, you'll see that it approaches p equals 0. So what do these horizontal asymptotes really mean, right? So with these type of logistic curves where they have two horizontal asymptotes that bound the function, what it really means is that if you're releasing these animals into this forest for this amount of time, we will never exceed 1,000 animals or go below 0 animals, which makes sense, right? We'll never have negative number of animals, but we'll also reach a limit at 1,000, that it's physically impossible for there to be more than 1,000 animals, maybe because there aren't enough resources or not enough space. So that's what these horizontal asymptotes mean in terms of this function and in terms of this word problem. And that is how we solve this problem.